3 Reasons Not to Expect a Mini Ice Age in 2030. Even though Earth is already in an ice age, a surplus of ice is the least of our worries. You can probably keep your igloo building skills on ice for a while longer. Despite a recent flurry of news reports suggesting Earth is just 15 years away from a mini ice age, we're still in far more danger from global warming than global cooling. The source of those reports is a new model of the Sun's solar cycle, released last week by Northumbria University mathematics professor Valentina Zarkova. The model offers fresh details about irregularities in the Sun's 11-year heartbeat, the same cycle that influences solar storms and the northern lights. Specifically, it predicts a substantial decrease in solar activity over the next couple decades. Many news outlets, especially those with a less than stellar track record of reporting about climate change, have seized on a particular line from a press release about the model. Predictions from the model suggest that solar activity will fall by 60% during the 2030s, the release states, to conditions last seen during the mini ice age that began in 1645. Also known as the Little Ice Age, this was a period of a few centuries marked by unusually cold weather in the northern hemisphere. It was not a true ice age in scientific terms, but it was really cold, and it correlated with a big dip in solar activity. So if the solar cycle is about to experience another big dip, that means the ongoing growth of global warming will screech to a halt and we'll all freeze, right? Maybe. But very probably not. Here are 3 important points to keep in mind. 1. Technically, Earth is already in an ice age. The phrase ice age gets thrown around a lot, so its exact meaning is understandably muddled. But it's worth noting that Earth has been in an ice age for about 3 million years, while modern humans have only been around for about 200,000. It's also worth noting that most people don't really mean ice age when they say ice age. The current ice age is one of at least 5 in Earth's history. Each ice age is punctuated by shorter cycles of relatively warm weather when glaciers retreat, interglacial periods, and cold cycles when glaciers advance, glacial periods. Sometimes people refer to these glacial periods as ice ages, which can be confusing. The current interglacial, which includes the Little Ice Age, aka Maunder Minimum, began about 11,000 years ago. Research suggests it may last another 50,000 years. Even if the predicted drop in solar activity does significantly affect Earth's climate, no one is saying it would usher in a new glacial period. At most, a mini ice age would likely resemble the Little Ice Age of 1645, which didn't involve globally advancing glaciers but did involve local glaciation as well as agricultural hardship for northern Europe. Still, there's ample reason to doubt even this milder outcome. 2. The link between sunspots and global cooling is hazy. The new solar cycle model is not yet published in a peer-reviewed journal, as the Washington Post points out, meaning it's still a bit preliminary. But even the scientists who created it didn't predict a mini ice age in their press release. The conditions they mentioned are on the Sun, not Earth. Those conditions were last seen during the mini ice age, as the press release notes, but the researchers stop short of explicitly blaming the cooler climate on a scarcity of sunspots. Still, they do seem to imply a connection. And they wouldn't be the first. The correlation between solar activity and the Little Ice Age is notable, and it's often touted by those who doubt the proven influence of carbon dioxide on climate. Scientists acknowledge the Little Ice Age may have been partly caused by low solar activity, but few believe that was the only cause. The period also correlated with a series of major volcanic eruptions, which are known to block solar heat. And even if the Little Ice Age was partly due to the solar cycle, that correlation hasn't held up in modern times. Solar activity has been generally declining since the mid-20th century, yet Earth's average temperature has been notoriously soaring at a pace unprecedented in human history, see graph below. While the recent solar maximum was the weakest in a century, 2014 was the hottest year in recorded history. So if solar cycles influence our planet's climate enough to spur mini ice ages, why isn't the recent decrease causing even a minor drop in temperatures? There is evidence that solar variations play a role in Earth's climate, but it's hardly a leading role. And it's apparently now being upstaged by another, more local actor, CO2. 3. The link between CO2 and global warming is clear. Carbon dioxide emissions from human activities are widely recognized as the main reason for the extreme greenhouse effect we've seen over the past century. The amount of warming is unusual, but the main problem is its pace. Earth's climates have changed naturally plenty of times in the past, but the speed of modern warming is unprecedented. It's rapidly recreating atmospheric conditions last seen in the pre-human Pliocene epoch, which means our species is entering uncharted territory. Even if the decline in solar activity does have an Earth cooling effect akin to the Little Ice Age, there's little reason to think that will save us from man-made warming. A study published in 2014 suggested a grand solar minimum could slow down but not stop the global warming caused by humans, adding that after the solar minimum ends, warming nearly catches up to the reference simulation. Another study published last month reached a similar conclusion, finding that record low solar activity could significantly influence regional climates for decades, but not enough to offer much relief from long-term global climate change. Any reduction in global mean near-surface temperature due to a future decline in solar activity is likely to be a small fraction of projected anthropogenic warming, the study's authors write. While that might soften the blow of global warming in some regions, any such cushion would be minor and fleeting, since a solar minimum typically lasts decades. CO2, meanwhile, tends to linger in the sky for centuries.